Hey kids, welcome back. And at Kitchen Table Chemistry, a whole another day here, May 6th. And our objective today is to be able to determine the concentration of an acid or a base through titration. And this will be an applied pH skill. So, titration, what is it? It's a method for determining a precise concentration for an acid or base in the lab. You start with one known concentration, either the acid or the base, and you use it to find the other. And this would have been about the last three labs that we would have done this year. We would have set up an apparatus that looks like that one on the page there, where we would have had this thing called a burette, which is a really accurate liquid measuring device. And we would have dripped into that, into this Erlenmeyer flask, a solution to find what's called an equivalence point, and that would have let us find the concentration of an acid or a base. Now, there's an equation to this. Titration equation looks like this. The molarity of the hydrogen times the volume of the acid is equal to the molarity of the hydroxide times the volume of the base. So it looks like this. You're just simply multiplying the two together, and it's a pretty straightforward thing. Little vocabulary lesson as we go. A hydrogen ion, which is H plus, is usually called a proton. Uh, so adding a hydrogen to something is protonation, and taking a hydrogen off is deprotonation. So, all right, this is already the second time through on this video, so I'm not going to change it for a spelling mistake. So protonation and deprotonation is the adding or the subtracting of a hydrogen. Okay, so you need to have the molarity of the hydrogen or the hydroxide, not just the molarity of the acid and the base. So let's look at this first example up here. What is the molarity of hydrogen ions in 1.5 molarity sulfuric acid? So we have 1.5 molarity sulfuric acid, H2SO4, and there's two hydrogens in it. So two hydrogens for every one H2SO4 sulfuric acid means we have 3.0 molarity for our hydrogen ions or our protons. Here, with the hydrochloric acid, it stays the same because there's only one hydrogen. So 1.5 molarity hydrochloric acid, one hydrogen ion for every one HCl, is going to give us 1.5 molarity, but our unit has changed to simply the hydrogen ion. Here, this example is acetic acid, and only the first hydrogen is going to come off of this. And so it's HC2H3O2. We're not going to count hydrogens that are not on the front of this thing. So I'm just showing you this. So it'll be 0.50 molarity times one hydrogen for every one HC2H3O2, and it will stay the same at 0.50 molarity H plus. So you see it most easily there with the acetic acid, which of course is also what's in vinegar. Now, here it works the same with it works the same with the base. So with the barium hydroxide, 3.0 molarity barium hydroxide, and there's two hydroxides in every one barium hydroxide. So therefore, the hydroxide molarity, I hate running out the screen on this thing. The hydroxide molarity here, I'm going to put it over here, OH minus, will be equal to 6.0. And that is the Y of it. You have to multiply the molarity times the number of particles that you're looking for, either the hydrogens in an acid or the hydroxides in a base. Okay, here I'm going to give you a couple of different titration problems. Now, what is the volume of 0.100 molarity hydrochloric acid? So the molarity of the acid then, the molarity of the acid is 0.1008. I'm looking for the volume, so that'll be the X that I'm trying to find. To neutralize completely, 25.00 milliliters, so that's the volume of my base. And it's 1.200 molarity. And it's only a single hydroxide on here, and there's only a single hydrogen here, so we don't need to worry about multiplying our or dividing any numbers. So I simply go into my formula, my formula, volume of the acid, where'd that go? Okay, times molarity of the acid is equal to the volume of the base times the molarity of the base. And the volume of the acid is the unknown here, times the molarity of the hydrogens, or the molarity of the acid, which in this, because it's monoprotic, is 1.008 molarity, is equal to the volume of the base, 25.00 milliliters, times its molarity, which is 1.200 molarity. And I got a volume of the acid required here of 297.6 milliliters. Quite acceptable to leave that answer in milliliters. It's a very, very large volume, but if you take a look at the difference here, this is 0.1 and this is 1.2. So there's a huge difference, a 12-fold difference in the concentration of the two. So we would expect a large volume of the acid. The answer makes sense. Let's take a look at a second problem here. Here's problem number 2. What is the molarity of a calcium hydroxide solution at 13.50 milliliters? So the volume of the base then is 13.50 milliliters. Is neutralized by 17 milliliters, so that's the volume of the acid. And it's 0.8 molarity hydrochloric acid. So 0.80 molarity. No reason to do anything with that. Now this is calcium hydroxide, so we are going to need to treat our answer at the end. So let's get a quick answer first. Volume of the acid times molarity of the hydrogens, in this case molarity of the acid, times the volume of the base times the molarity of the base. Now, okay, so we have 17.00 milliliters times 0.80 molarity is equal to the volume of the base, which is 13.50 milliliters times the unknown, which is this molarity of the hydroxides. And I solved for this, and I got a molarity of base, in this case, equal to 1.00 molarity. Okay, now because this is calcium hydroxide, what I now have as my answer is 1.00 molarity hydroxide. Ignore the dot. And what we're going to do is this. For every 1 mole of calcium hydroxide, which has 2 hydroxides on it, there's 2 hydroxides. So this, in effect, is going to cut our answer in half to 0.05. That will be molarity of calcium hydroxide. And that's how that works. Okay. A couple titration problems solved for you there. I gave you a few to do, just a couple to try here for Wednesday. Tomorrow we'll be taking a quiz on pH calculations on Thursday. As always, let me know if you're struggling or you've got any questions. Some of you guys are sending some amazing questions to me. I won't point people out, but it really helps me in my teaching as well. Hope you're doing well, and take care. Bye-bye.